Hey guys, it's Miss B. So we're back. It's week 5 and we are continuing on with unit 2, and the next part of equations is modeling and solving. So far we've been focused on writing equations, and now we are actually going to go ahead and solve them. So we're going to know how to represent an equation using algebra tiles, and understand that using the inverse operation helps us isolate the variable in an equation so that we can solve. And we will be able to model and solve an equation with one variable on both sides of an equal sign arising from a mathematical or real-world problem. Okay, so today we're mainly going to focus on the first two, which is modeling and solving. Okay. All right, so the next thing we want to discuss, we want to review the algebra tiles and what they look like and what they're representing. So if you notice in the table, it has positive and we have our negatives. So the variables are going to be represented by the long rectangle tile, and they'll have an X on it. It'll have a positive X. Oops, let me go back really quick. Positive X or a negative X. And again, most of the time the positive ones will either be green or like a yellow of some sort. And if we look at the units, it'll be a smaller square unit that either will have a +1 or just a 1 to represent it being positive. And here on the negative side, same thing, it's just the opposite. Again, most of the time the negatives are represented using red, and it has a negative X on the variable and then a -1 on the unit. Okay, now when we're solving these, hopefully you remember this zero pairs. Okay, again, when we have a positive and a negative either variable together, that creates 0, or if we have a +1 and a -1, it also creates 0. So we're going to use these zero pairs to when we really solve to isolate the variables. Okay, and zero pairs is the same thing as using the inverse operation when we're modeling equations. So let's travel back in time to 2 years ago in 6th grade when we first started solving equations. So in 6th grade, we started to solve one-step equations that look like this. So a very simple equation, x + 5 = 7 is what you focused on in 6th grade. And it says, remember, when we're solving equations, our goal is to isolate the variable to figure out what number the variable is representing. So we want to get this x by itself here. Okay, that's our main goal, so we can figure out what number it's representing. Also, key thing is we want to focus on that this is an equation, guys. So the left side and the right side are equal. They just look and are using different terms. So on the right side, I just have 7. So I know that this left side has to equal 7. It just depends. It just looks different, okay? So let's go ahead and actually solve. Okay, so we're going to use these algebra tiles, and I'm going to, all right. So I have this little interactive algebra tile board here where we can drag and drop these tiles to help us solve. So the first thing I want to focus on is the left side of the equation. I want to represent this side first. So it has 1x and it's positive. So that's going to be yellow for this interactive board. And then I need to add 5 positive units because of the plus sign. So 1, 2, 3, 4, 5. And we just use this board by dragging and dropping. So you just drag and drop whatever you need. Okay, so I have x + 5, which matches x + 5 on the left. On the right side, I need to represent this +7. So I'm just going to add the positives, and I'm going to make sure that I have 7. All right, 2 more. Okay. So I have 7, which matches 7. So now I can actually solve. Okay. So again, our goal is to get this x value by itself to figure out what it's representing. Okay, so I need to get rid of these +5s. In order to do so, I'm going to do the inverse operation, or the opposite. So instead of adding 5 or adding +5, I'm going to then represent that with a -5, or I'm going to subtract, do the opposite, the inverse operation. Okay. But before I want to start creating zero pairs, since it is an equation, our equation must remain balanced at all times. Meaning if I do something to one side, I have to do it to the other side to keep it balanced. So since I added these -5 here, I also need to add it to this side here so that way my equation can remain balanced, okay? Okay. All right, so now I've added the 5 here, but now since I have positives and negatives here, I can create 0 pairs. And this little interactive thing, if you just hover them over, they go away. They create 0 pairs. So a positive and a negative. Okay, so I'm going to keep creating these 0 pairs until I can't anymore. Okay, so perfect. Now I'm left with x, which is what I want, but look at this left side here. We need to create 0 pairs on this side as well. So again, I'm just going to drag and hover them over until I cannot make any more 0 pairs. Okay, and so now I have x equals 2. Okay, so again, x is by itself, which is what we wanted, and we have 2 over here. But again, now we're able to use calculators, so we can always go back and double check. So if x equals 2, I'm going to put it in my calculator and see if it's correct. So here, 2 plus, or x plus 5 should give me 7. So I'm going to substitute for x, I'm going to substitute 2. Oh, let me turn my calculator on. Clear. So 2 plus 5 should equal 7 if my equation is true. And yes, it does. So yes, my solution for x plus 5 equals 7 is x equals 2. Okay, and I can double check that in my calculator. Okay, so let's journey back just 1 year where you were in 7th grade and you had equations that look like this. So in 7th grade, you did 2-step equations. So you added just one more step. And just again, as a review, we're going to go ahead and model this equation and solve. But if you think you can try it on your own, feel free to pause the video and give it a try. Okay, guys, so I went ahead and filled out my model. I got my tiles. I have 2x plus 3 on the left, which matches, and then I have positive 11 on the right side. Okay, so we want to solve for x, meaning we want to get it by itself. So here, instead of doing one step, we're going to have to do 2 steps. So again, our goal is to get this x by itself. So first things first, since I'm going to start on the left side since the x is on the left side. And before I can get to the 2x part, I need to work with this plus 3. And so again, I want to do the inverse. So if I want to cancel these out, I need to add then -3. Okay, and so if I do it to the left side, I must do it to the right side again because it is an equation. It needs to remain balanced. Now I can create these 0 pairs. Okay, so again, those just hover over and they go away. And again, on the right side, I'm going to create 0 pairs. Okay, now I'm still stuck with 2x equals 8. But again, I only want x by itself. Now, the 2 and the x here are held together by multiplication. Again, remember I talked about they're side by side, they're married, stuck like glue, multiplied. So I want to divide these, or I want to separate them into groups. And since there's 2x, I'm going to separate it into 2 groups, 1 and 2. So here's one group and here's 2 groups, with each group having 1x. And then I'm also going to do the same with the units here. I'm going to divide them one at a time. And let me move these just out of the way just a second. So I'm going to divide these into each group until I can evenly, until I don't have any more. So I put 1 there in that x group, 1 here. I'm going to keep doing this until I don't have any units left to separate. Okay, so put that there. All right, so I don't have any more to separate. So now I can see one of these x's, x equals 4, and it's a positive 4 because they're all positive. So x equals 4. All right, now again, but I want to double check myself, so I'm going to put it in the calculator. So 2 times 4 plus 3 should give me 11 if we are correct in our solution. Yep, it does. Okay, so again, we want to make sure that we are checking and that we are creating those zero pairs correctly. All right. Okay, so let's look at our second example. So this example is a little different because I moved the variable from the right side to the left side. And we need to know that, well, we need to be able to also solve with the variable being on the left side. So this equation says 21 equals 9 plus 3x. So I'm going to pause the video for a second and set up my tiles. Okay guys, so I've represented my equation using the algebra tiles. I have 21 on the left side, and then I have 9 plus 3x on the right side. Okay, so since the x is on the left side, on the right side this time, we want to start with that side. So again, our goal is to still get this 3x by itself or x by itself, but first we need to cancel or get rid of this plus 9. So we're going to do the inverse operation by creating 0 pairs. So I'm going to, since I have 9 positives, I need 9 negatives. So I'm going to add these 9 negatives. 6, 7, 8, 9. Okay, and again, it is an equation. It needs to remain balanced. Since I added 9 negatives here, I need to add those 9 negatives here. So I'm going to add those really quickly. All right. And 2 more. Okay, so now I can go ahead and create my 0 pairs since I've done it to both sides here. And if you notice, I don't create my 0 pairs till I've added to both sides, because again, I want to make sure that I'm keeping my equation balanced at all times, which is very important, super important. Okay, so I'm created my 0 pairs here on the right side. I'm going to do the same thing on the left side. Okay. And I'm going to go ahead and share the link with you for this algebra tile mat, so that way if you want, you can go ahead and use it. I suggest to use it. It's very helpful to just get a visual of what is happening. Okay, so now I'm left with 12 on the left side and 3x on the right side. And again, since the 3 and the x are held together by multiplication, I need to divide those into 3 groups. So here's 3 groups, and I'm going to take my units and I'm going to divide those into each group until I don't have any more units. And again, we're doing this because we want to divide them evenly. Okay. Oops. Make that one a little nicer. So then if you notice, in each group we have 4. So 1x is equal to 4. Okay. So let's double check again ourselves. We always want to make sure it's correct. So we're going to put it in my calculator. Turn this on. All right. So I'm looking at the right side. So I want to say 9 plus 3 times. And if you notice, I'm putting the x in parentheses just to make sure. Okay. And then enter, and I should get 21. Yep. All right. So now we've reviewed one-step equations. We've reviewed two-step equations. And again, that's all 6th and 7th grade. But we need to focus on what we're doing in 8th grade. So how might that look? Okay, guys. So let's look at what our equations are looking like in 8th grade. And we've already seen these, guys. These are the kind of equations that we've been writing. Now we're just taking it that next step and actually now solving for x. Okay, so again, we have the same variable x on both sides, and we're going to solve in a very similar fashion as we've been doing. And I already have my tiles set up. I have 4x minus 2. Now this minus 2, okay, is being represented with these negative 2's. Okay, so minus 2. And then I have 3x plus 1 on the right. Okay, so first things first, when there's equations on both sides, the first thing you want to look at is the coefficients with those variables. So on the left side, the coefficient is 4. On the right side, the coefficient is 3. Okay, now we want to get our x by itself, and our x must always remain positive. So If I were to take this 4x and move it to the right side, I would have to subtract that, and then my x would be negative, which I don't want. So it's important to understand which x do you want to move, okay, in order to be able to keep your x positive. So here I'm going to take the 3x, I'm going to move it, or I'm going to subtract it from the left side first, so that way I can keep my x positive. And how we're going to do that is using our algebra tiles. So here I have the 3x on the right side, and in order to get rid of that, I need to do the opposite. So if they're positive, wrong one. If they're positive, I need to go ahead and add my -3, or subtract. Same thing as subtracting 3x. Okay, and if I add the -3's to the right, I need to also add them to the left. All right. And again, if you notice, before I'm creating the 0 pairs, I want to make sure that I'm doing it to both sides first to make sure I'm doing the same exact thing, because again, it is an equation and it needs to remain balanced at all times. So now I'm going to create these 0 pairs with the x's. Okay, so that should just leave me with 1 unit on the right. Okay, same thing on the left. I'm going to create those 0 pairs. All right, got it. Okay, now I'm left with x minus 2 on this side and positive 1 on this side. Okay, but again, my goal is to still get this x by itself, so I need to take another step, and I need to get rid of this minus 2. So I'm going to add 2. And again, if I do it to one side, I must do it to the other. So I'm going to add 2 to this side as well. And then again, I'm going to create my 0 pairs. So I finally have x by itself, and it equals 3. So again, I want to make sure, so I'm going to plug it into my calculator. Now, since there's variables on both sides, okay, I want to focus on the left side first. So if we said our solution is x equals 3, first I'm going to take 4 times 3 plus 2 and see what I get. Oh, I'm sorry. Oh, this should have been a minus 2. Minus 2, and I get 10. Okay, so if I get 10 with that side, the left side, I should get 10 on the right side by plugging in the same solution. So 3 times, and we said our x was 3 plus 1. I should get 10 as well. Yep, and that's how you know your solution is correct. So for this equation, x equals 3 is the correct solution. Okay, let's move to example number 2. Okay, so I'm going to get rid of this calculator. I'm going to clear my board. All right, so the second example, 7 minus 2x equals x minus 8. Okay, so if you want to go ahead and try this one, pause the video and come back and see if you're correct. And I'm going to go ahead and get my tiles set up. All right, guys, so I got my board set up with the tiles. Again, I have 7 minus 2x, and since this is a minus 2x, I represented that with the -2 tiles, 2 x's, and then I have x minus 8 on this side. Again, I have my positive x, and then with this minus 8, I represented that with -8 tiles. Okay, so first off, again, when there's equations on both sides, we want to focus on the coefficients of the x. So I have a positive x on the right, but I have -2x here. So if you were to think about it, if I were to move this x from the right to the left, I would still get a -x. And again, we always want a positive x. So instead, I'm going to get rid of this -2x by moving it or subtracting it from the right side. So first, I'm going to, in order to cancel out or to get rid of these -2x, again, I need to do the opposite or the inverse and add positive 2x. And again, if I did it to one side, I have to do it to the other. Okay, now I can create those 0 pairs. All right, so this is gone. And there's no 0 pairs for me to make here with the x's, so that just remains 3x. Now, again, my goal is still to get these x's by itself, and it's right now attached to this -8. So I have to, again, create these or do the inverse operation. So instead of subtracting 8, I want to add 8. All right, so there's 2, 3. All right, one more. Okay. And now if I added 7 to this side, I need to add 7 to this side. I'm sorry, 8 to this side. I need to then add 8 to this side. So I should get, okay. And now I'm going to create my 0 pairs. So again, you just drag and hover over and they just disappear like zeros. All right. Okay. And I know a lot of y'all guys are not fans of using the algebra tiles, but they do allow you to see what is happening and how we're using those inverse operations to create those 0 pairs to mathematically move numbers around. All right, so I have my 3x over here, and again, it's held together by multiplication. So I want to separate them into 3 equal groups, meaning I want to divide by 3, same thing, 3 equal groups. I'm going to do the same thing with the units over here on the left. I'm going to separate these into these 3 equal groups until I don't have any more to separate. Okay, well, I guess I'll just move this down there. Okay, so I'm going to keep doing this until I don't have any more to group. And again, we're dividing, guys. Remember, when we're putting things into groups, that we are dividing. Okay, so this is exactly what I'm doing. The inverse operation in multiplication is division by 3. Okay, so now I have 3 groups, but 1x, okay, 1x here is equal to 1, 2, 3, 4, 5, positive 5. So x equals 5 is our solution, but again, I don't want to just stop there. I want to make sure that it's 100% correct. So I'm going to plug it into the calculator. I'm going to start with the left side first. 7 minus 2 times 5. Okay, I get negative 3. Okay, so again, I'm going to go to the right side, and I should get negative 3 if my solution is 5. So where there's an x, I'm going to put 5 minus 8, and I get negative 3. So yes, x equals 5 is our solution for this example. Okay, so the next thing I wanted to talk to you about is this exit ticket, giving you the opportunity to, sorry, skip that. Okay, so here's your exit ticket for today. I'm giving you the option. You can choose either A or B, but you need to choose one. It says choose a problem and solve for X. Leave your answer in the discussion. Click the link, click this button, and it gives you a little picture of the button to use the interactive algebra tiles. So if you click this button here in the discussion, guys, it'll open up this interactive board that I've been using, so you can go ahead and move the tiles and solve that way. So you need to choose A or B, which equation you want to solve. And then in the discussion, if you choose A, then you just put A and then X equals whatever the solution that you get. Same thing if you choose B, then you put B and then you put X equals and your solution. Okay, and then make sure you submit it. All right, guys, so I hope this helps. If it doesn't and you need more clarification, please join me at the lives every day at 9:30 and 2. And I hope you have a great Monday.